Alright, the first problem I want to do is this one. It says let f be the function defined by, and it gives us a bunch of ordered pairs, and let g be the function defined by this, g equals a bunch of ordered pairs. Find the following value if it exists. We want to find f of g of 3. Well, normally when we've been doing these, we've had actual functions. You know, f of x equals some number x, had an x in it, some equation. Well, this one I don't have an equation. I just have a set of ordered pairs. But let's still remember what it means to do f of g of 3. That's another way you might see it. We want to start on the right side and work our way to the left, basically. We want to start with g of 3, figure out what g of 3 would evaluate at, and then work from there. So g of 3 means when x is 3. When x is 3, what would the y value be? What would it evaluate as when x was 3 in the g function? So I look to the g function, and I look for a value of x being 3. So I see it right there. When x was 3, looks like y is 2. So because y is 2, when x is 3, g of 3, I'll write it to the side here, g of 3 is 2. When we're doing a composition of functions, the output of this function output of this g of 3 function is going to be the input of the f of x function. So now that I got my output of 2, I'm going to put that into my f function, find out what f of 2 is. So f of 2, now I'm going to look to my f function, look along the ordered pairs, see where I see an x value of 2, and see what the output of that is. Output of that would be 5. So g of 3 was 2. That told me I needed to do f of 2 to get 5, and 5 would be my final answer there. The next one I want to do is this one here. Write the following as a composition of 2 or more non-identity functions. So this is kind of working backwards. We're already given something that has had a composition done to it. I want to pull it apart and see from what two functions it came from. So if we're trying to find g of f of x, another way you could see that is g of f of x. That means I'm putting the f of x function into the g of x function. So the f of x must be the one that is going into the other. So from looking at this expression up here, I can see a few things happening. I can see the x squared minus 9. That whole quantity is being cubed. The x squared minus 9 is being cubed. So what if, and sometimes you have to play around with a little bit and try to pick some values and see if it would work. But what if I let f of x be x squared minus 9? And then I let my g of x just be a quantity x cubed. Let's see if that would in fact give us this function here. So f of x is x squared minus 9, g of x is x cubed. If I did g of f of x, like it said here, that means I'm going to be putting the f of x function into the x spot of the g function. So let me look at the g function. It's x cubed. Instead of writing x cubed, I'm going to write a blank cubed, because it's not going to be an x anymore. I'm putting something into this x spot. So it's not an x cubed anymore, it's a blank cube, blank spot. In that blank spot, I'm supposed to put the other function, f of x. So I'll put my other function, x squared minus 9, in there. Let's see if it turned out to be what we wanted it to be. It did. X squared minus 9 went into the thing that was being cubed, and that is what we had originally. So that would be our two functions. F of x would be x squared minus 9, g of x would be x cubed.